So now let's practice rewriting something in terms of only sine and cosine. So I want to be very specific in this case. I want my answer or my solution to have only sine and cosine in it. I don't want any quotients, or in other words, any fractions to appear in it if possible either. And I'm again trying to, if possible, simplify this down so that only sine and cosine appear. Let's start with this one right here. We want to look at the cotangent theta sine theta, and I want to rewrite this basically getting rid of cotangent. I do that by saying, what can I replace cotangent with? And only leave it in terms of sine and cosine. Well, I can rewrite cotangent as cosine over sine, and I'm still multiplying this by sine. So the rules of fractions, in algebra are still going to apply because I want to simplify this now. Sine theta is going to cancel diagonally, and this just leaves me in cosine theta. So that's a pretty simple example, but it kind of gets us going in the right direction. Let's look at this next one. Sine squared theta times cosecant squared theta minus 1. So anytime you see a function minus or plus a 1, you probably want to start thinking about the Pythagorean identities. So I can rewrite cosine squared theta minus 1 as cotangent squared theta, because that's the Pythagorean identity, and I still have sine squared theta here. So all I did was rewrite this portion here using the Pythagorean identity as cotangent squared theta. Now again, I'm wanting to try to simplify this as far as I can and get rid of cotangent, so I replace cotangent squared. I know that I can rewrite this as cosine over sine, but cotangent squared, so I would have both of these squared also. So again, fractions will reduce diagonally, and so will these trig functions, leaving me with just, let me give myself a little more room here, leaving me just cosine squared theta. Okay, so Pythagorean identity and the quotient identity are going to be key here. Let's look at this next one. Here I have some binomial multiplied by another binomial. In it, secant theta appears in both of them, and 1 appears in both of them. Anytime you have something that looks like this, you might want to think about FOIL. Okay, what happens if I FOIL these two terms together? Well, I get the square of the first term, which is just secant squared theta, and outer and inner cancel, leaving me with just secant squared theta minus 1. Secant squared theta minus 1, hopefully, ding ding, you should be thinking Pythagorean identities, is just a manipulation of tan squared theta. Okay? So I can rewrite secant squared theta minus 1 as tan squared theta. Now, the instructions are telling me that I want to try to get this down into sine and cosine, but if I do that, if I were to rewrite this using the quotient identity of sine squared theta over cosine squared theta, I would introduce a fraction into what I've been doing, and I don't want to do that. So this is my final answer because there are no fractions in that solution. Even though it's not listed as sine or cosine, I kind of don't want a fraction over the idea of it having to be in sine and cosine. Okay, and lastly, let's look at this. 1 plus tan squared theta divided by 1 minus secant squared theta. So Pythagorean identities, they don't always come in the form, though, that we like to look at them as. The numerator, I know, is secant squared theta. But the denominator is not just going to be as straightforward as you think. So let's take a second. I want to rewrite the identity over here. I know that the identity says I have tan squared theta plus 1 is equal to secant squared theta. If I subtract 1 to the other side, that leaves me with tan squared theta is equal to secant squared minus 1. Now, secant squared theta minus 1 and what's showing up here in the denominator are so close that you want to use it, but you can't, because here I have a negative 1 and up here I have a positive 1. So they're reversed by a negative value. What would help here is if I just multiplied tangent by a negative. Let me write that a little better. Then if I multiplied everything in here by a negative 1, I would end up with a negative tangent squared, a negative secant squared, and a positive 1, which is ultimately the form that I need it to be in. Okay, so again, I have secant and tangent, which may be okay, maybe not, but I definitely don't want fractions here. So let's go ahead and see if I can take this any further to get rid of the fractions that show up. So secant squared theta can be written as 1 over cosine squared theta. Tangent squared theta is going to be, let's say, negative sine squared theta over, sorry. Tangent squared theta is sine over cosine, but because I'm dividing by tangent, I multiply by the reciprocal. In other words, this becomes cosine squared theta over sine squared theta, and it was a negative. Okay, so understand that secant squared theta is the first term, and since we're dividing, we're going to change to multiplication and multiply by the reciprocal of the denominator, which ends up looking like this. Here you can see that cosines are going to cancel. That gives me negative 1 over sine squared theta, but ultimately I want to try to get rid of my fractions, so I'm going to rewrite this as negative, using the reciprocal identity, negative cosecant squared theta. So that's what I ended up whittling it down to.